Greetings, students. This is the first unit of pre-algebra, and so I also want to just put it out there right away that initially this might seem super easy, but it does get pretty deep. It goes into what partway into what I used to do in the second unit of Algebra 1 as of last school year. And so just hang in there. I will try to get you placed in the correct class if this isn't the right class for you. But today we're going to talk about some integers and exponents review, and that will be our first order of business here. So in your packets, you have this information. It just reviews the operations and the rules. And so just a little bit, should not need to use a calculator for this. These numbers are nice and small. Get used to using your brain, but also just get used to using those rules. And so let's see here. Let me turn on some annotations. There we go. All right, so I'm just going to go through and do just a few of these, and then I'll pause, I'll fill it in. Actually, I probably won't pause since I'm on Zoom. So probably just going to do a few of these though. All right, so I can get into the quote new stuff. So we have some different operations here. And so if we're just adding and the signs are the same, we are actually going to add and keep that sign. So two positives still add up to a positive. Nothing's changed there. These two negative numbers will add up to a -6, a -4, and a +2. So their signs are different. So we'll actually subtract the number parts. 4 minus 2 is 2. But the larger number is the negative number, the larger absolute value. So it is -2. On the contrary, 4 plus -2 will be +2 because the larger number is positive. Subtraction, we have our really straightforward usual subtraction. 4 minus 2 is 2. And then this is when you want to really think about the rule that says either keep, change, change, or that you add the opposite. When you see the double negative without a number in between, it's going to make both those turn into plus. So that problem becomes -4 plus +2. And if I have different signs, I will have to subtract, and the negative is bigger. So it basically turned into the one that's diagonal to the left. So again, anytime you see the two negatives, plus plus, so this is going to be 6, this will be -6. So whether I just think of that like the sign is attached to whatever follows, -4, -2, -6. If I want to use my add the opposite rule or keep, change, change, I can. It then would become -4 plus -2. And again, that would still be -6. Multiply and divide is much easier. Multiply and divide as normal. And then if the signs are the same, your answer will be positive. If the signs are different, your answer will be negative. So 4 times 2 is 8. -4 times -2, signs are still the same. That is still +8. Might be tempting to think it's negative, but it's kind of like it really has two negatives, one from each of them, and then the negative, like the opposite of the opposite, just takes you back to where you were. So it's just 8. -4 times 2 is -8, and 4 times -2 is also -8. So it doesn't matter who's bigger in multiplying and dividing. If you just have one negative, it's going to be negative. So 4 divided by 2 is, of course, 2. 2 negatives, still positive. 1 negative, negative, 1 negative, negative. I guess I kind of lied because I went ahead and did all of those. So let's see here, clear those off. You can always rewind if you need to. See what we've got coming up. Turn my pencil off to scroll. So another thing we need to review is exponents. So you might recall that exponents is repeated multiplication of the base. So the base is the large normal size number. The exponent, sometimes also called the index in some languages or in some places. The index is the small raised number. And that small raised number tells you how many times to use the base. So 4 to the 3rd power means 4 times 4 times 4. There are 3 4s written out. And then we just go from left to right. 4 times 4, 16, times 4 again is 64. All right, so we've got some pretty manageable numbers here. Like 4 to the 3rd power, also, by the way, called cubed. So 2nd power has a special name. It's also called squared. So sometimes I may say squared instead of 2nd power. And 3rd power is also called cubed. Perfect. So remember that this means 3 times 3, sometimes something like squared. You might just know off the top of your head. So that would be 9. 2 to the 5th power. This is going to be 2 times 2 times 2 times 2 times 2 times I ran out of space. So 2 times 2 is 4. Times another 2 makes 8. Times another 2, 16, times another 2, 2 to the 5th power is 32. All right, 32. So I'm going to erase a little bit of my excess work from that problem. So 1 is an interesting character. 1 to any power is still 1, right? No matter how many times I multiply 1 times 1, it's always 1. So whether it's the 6th power, the 600th power, doesn't matter. It's just equal to 1. So 5 squared, also known as 5 to the 2nd power. What do you think? 25. Yes, 5 times 5 is 25. So we already did 2 to the 5th power. So 2 to the 4th power would just be like one step from the end. So if I take my 32 and divide it by 2, that would have been 16. Or I could start over and do 2 times 2. Some of these you'll kind of get used to seeing, and they'll become more familiar. 10 to the 1st power is 10. 7 squared, 7 times 7, 49. All right. Now in our classroom, we have calculators that have this button. Kind of I'd refer to that as my to the button. It's like the power button. So for instance, a shortcut, instead of going 2 times 2 times 2 times 2, and like, how many times did I put that in? You could just type in 2 to the 4th power is equal to, and then it would just give you the 16. So if you are going to use a calculator for some of these, like, get used to using the correct buttons instead of like use it to your advantage, right? Don't just back and forth. But the big takeaway, it does not mean, for instance, for number 7 there, it's not just 4 times 3, right? 4 times 4 times 4, not 4 times 3. Perfect. And then we did some order of operations. If you you may have seen me go through some of this during orientation. I have a nice colorful page in your packet that reminds you of order of operations. And there's a little mnemonic device to help you remember. Please excuse my dear Aunt Sally. I want to point out that my dear describes her, and Aunt Sally is her name. So P represents parentheses. Could be really any grouping symbol. Parentheses are the most common, but sometimes it could be a giant fraction. And that fraction bar is going to act like a grouping symbol, even without parentheses. Second, we're going to do any exponents, powers. We'll also do square roots on that step. That might be something new for you. And then multiplication and division. Remember I said my dear describes her? Multiplication and division, just left to right in the order that they appear. Do not skip over division to do multiplication. Just go left to right. And then addition and subtraction come last. Again, if it's intended that we kind of break those last rules, that's when they usually use parentheses, because then it forces you to do like addition and subtraction first. So you see, here's an example that has lots of steps, right? Lots of steps. And see how each time the rest of the problem that's not being done at that time is just getting brought down. So let me model a few of those for you. This just reminds us of this again. So we've got a few examples here. Some of them won't need nearly as much space as others. And let's see if I can make my screen nice and big so that I can write legibly. So kind of go through a checklist. Do I have an A? Do I have any parentheses? Nope. Do I have any exponents? No again. So the first thing I'm going to do is any multiplication or division that I see. And in this case, we have still used an X for multiply. Not for very much longer though. So 2 times 7 is 14. And then I encourage you to bring down the other numbers and symbols. Sorry about that. So now I have 3 plus 14 minus 4. So everything that's left is just addition and subtraction. So we'll simply go from left to right. So we can go ahead and do 3 plus 14. So 3 and 14 makes 17. And then 17 minus 4 is 13. And maybe you could have simply kind of kept 17 in your head. Minus 4 is 13. All right, I hope so. So in B, we're going to do what's in our parentheses first. They kind of scream at us. 20 times 2 is 40. And then the next thing we're going to do is do that exponent. So since I can rewrite this, or I could have gone ahead and done 4 to the second power or 4 squared, because it doesn't affect the 40. But just to kind of show each step, I just went ahead and rewrote it here. So then 40, and then minus is going to come down. 4 to the second power. So remember, that means 4 times 4. So 16. And then last step, 40 minus 16, 24. All right. So in C, no parentheses, no exponents. So everything's on those last two levels of multiply, divide, add, and subtract. be careful. Do not just simply go from left to right. We do need to jump over that subtraction. It's just going to have to wait because adding and subtracting don't come until the very end. So 18 minus is just going to kind of hang out and wait. The first thing that's going to happen is 10 divided by 2. And then times 3 is going to come down and wait. So sometimes people have in their head PEMDAS. But remember, multiply, divide are on the same line. So we don't just do multiply always first. Left to right if those are my two operations. So that's why in this case, divide comes first because it's to the left. Now we can multiply next. 5 times 3 is 15. 18 minus is just waiting patiently. 18 minus 15 is 3. Final answer. And you may have other ways that you show it's your final answer. Some of you may do something like this in the corner, underline it. If it's pretty clear and your work has plenty of space, you don't have to box your answers or something, but oftentimes I do. All right, so you're going to have some homework. See, we got some order of operations practice. Lots of practice, all right? So some of these may be a little bit different. They all follow those same order of operations. So you have 12 order of operations problems. All right, I hope to see you in class soon. If you're watching this, it probably means you missed the very first day of class. You may be watching this to try to get caught up, but I hope it was helpful, and I will see you soon. Thanks.